Hello, dear students of grade 11. Today we're going to study the fourth lesson of chapter 1, section 1, and we reached balancing chemical equations. Many students have face difficulties in balancing chemical equations, but actually balancing is pretty easy if you follow some rules, some steps, and keep in mind balancing chemical equation is a process of trial and error. So maybe the first attempt it wouldn't work. So try another coefficient, change the coefficients. Anyhow, let's go on. So we have balancing chemical equations, which means it is applying of mass conservation law, which means number of atoms of each element in reactants must equal the number of atoms of the same element in the products. So in order to balance chemical equation, you're going to follow some steps here. The first step is we start with the element we're going to balance each time atoms of one element, which means we balance atoms of one element, later go to another element. So first thing, we balance each element one at a time. We balance each element one at a time, which means we don't move to another element until we balance one element. Second, with which elements we should start? If there are elements combined and appear once in both sides, we start with them. If there are elements combined and appear once in each side in reactants and products, we start with them. Second, we're going to balance the polyatomic ions. The polyatomic ions, we have, for example, hydroxide. You see this ion composed of two atoms, oxygen and hydrogen, SO4, one sulfur and four oxygen, NO3 nitrate, one nitrogen and three oxygen, and we have many of them, many polyatomic ions. So we're going to deal with these polyatomic ions as single portions, as single units. We will not say we have four nitrate, we will have one nitrogen, three oxygens. No, we will say we will have one nitrate in reactants and how many nitrates in products, and we're going to balance by adding or putting appropriate coefficients. Finally, we balance hydrogen and oxygen, which means hydrogen and oxygen are left to the end. Of course, this doesn't include the oxygen or hydrogen present in polyatomic ions, because polyatomic ions are single units, and we're going to balance them in second step. So let's have an example and see what we have. Simplest example is equation of reaction of water electrolysis. So in water electrolysis, we have one here, water. In the beginning, we have one molecule of water by electric current produces hydrogen and oxygen. Of course, this is not balanced yet, simply because we have one oxygen in reactants and we have two oxygens in products. So what should we do? We're going to put the coefficient of 2 in order to get number of oxygen atoms and reactants equal to these in products, which are 2. Okay, we balance the oxygen, but this confused the hydrogen atoms, because we still have 2 hydrogen atoms in products, but we have now 4. 2 times 2, 4 hydrogen atoms. That's why we must add 2, coefficient of 2 in the front of H2 molecule in order to have H2 in both sides equal to 4. Now we can check. We have 4 hydrogen atoms here, 4 hydrogen atoms in the reactants and 4 hydrogen atoms in the products. We have 2 hydrogen atoms in reactants and we have 2 hydrogen atoms in products. So our chemical equation now is balanced. Let's move forward and have more examples. Actually, I wanted to share this figure or this picture with you. This represents the apparatus of electrolysis of water. So water is being electrolyzed by passing electric current through water, and bubbles of hydrogen here and bubbles of oxygen here. And you can see that the volume of hydrogen gas is twice as oxygen. Why? Because here we have two molecules of hydrogen in front of one molecule of oxygen. Despite oxygen is heavier than hydrogen, much heavier, but the volumes of gases depend on the number of molecules or number of moles. So the volume of hydrogen is twice as volume of oxygen. Let's move forward and see a practice from your book. We have practice 1B, aqueous nitric acid reacts. So we have aqueous nitric acid here. Here nitric acid reacts with solid magnesium. So these are reactants, sorry, with magnesium hydroxide, producing magnesium nitrate and water. So where are reactants, where are products? We have nitric acid is reactant, solid magnesium reactant, producing, what follows producing are products. So I have magnesium nitrate products, and also water is product. First thing we start when converting sentences into chemical equation, we're going to write the word equation first. So the names of reactants to left, names of products to right, and between them an arrow. So first thing, we write the word equation. Nitric acid solution here is reactant, solid magnesium. We mentioned to the physical states. Here we have aqueous solution and here we have solid. Yielding magnesium nitrate, also solution. So this is aqueous, and water is liquid. So far we made the word equation. Now let's convert it into formula equation. Our second step is formula equation. So you're going to write, instead of nitric acid, we will write HNO3, which stands for, HNO3, that stands for nitric acid, and MgOH by 2, that stands for magnesium hydroxide, and their physical states aqueous. Sorry, I think there's solid, so we must write here S. This is not aqueous, this is solid. And a product, also we're going to change the name into what? Into formula. So you have magnesium nitrate. The nitrate here is by 2, because magnesium is positive 2 and nitrate is negative 1. That's why we need 2 polyatomics of nitrate in order to balance it, to balance the positive 2 of magnesium. Plus what? Plus water. Water is liquid, of course. So far we have made the formula equation, but not complete yet. Why? Because it is not balanced. So we're going to apply the rules that we just studied in order to balance this equation. So we have first, what should we balance? We have magnesium appears once in both sides. So we'll start with magnesium. Why? Because we start with atoms of elements that appear once in both sides. So magnesium has one atom here, one magnesium atom. Okay. Second, let's move to polyatomic ions. Polyatomic ions, we have 2 nitrates here, but we have 1 nitrate here. So we need to make the 2 nitrate and reactant side 2, just like the ones present in, or the 2 presents in the product. So we're going to add coefficient of 2. Now we have nitrate is balanced, we have magnesium is balanced. We reached hydrogen and oxygen. How many oxygens other than the nitrate? Because the nitrate is already balanced. How many oxygens here? We have 2. How many oxygens here? We have 1. So we need to add 2 in front of H2 in order to get oxygen equal to 2 on both sides. So we have here 2 oxygens, and we have 2 oxygens here. Hydrogen, we have 1 hydrogen here, times 2 is 2, and the H here, other than the nitrate, also 2. So 2 plus 2, 4. We already had 4 hydrogen. So now we have 1 magnesium, 2 nitrates, 1 magnesium in each side, 2 nitrates in each side, 2 oxygens in each side, and 4 hydrogen atoms in each side. So it is balanced and our work is done. Let's move to another. Okay. We have practice the same. Actually, you're gonna find the difference in the page number. Why? Because this is the old numbering before transferring chapter 1 into the grade 10. Anyhow, it's practice 1B in section 1.1. Okay. We have here an example or practice. We have solid copper, which means pure copper in solid state reacts with aqueous silver nitrate. Solid copper reacts with aqueous silver nitrate, so both are reactants. This is a reactant and this is also reactant. The products are aqueous copper 2 nitrate, so this is a product, and solid silver, silver being purified, silver being subtracted after copper replaces it. Our first step is to write the word equation. So we're gonna write the names of reactants, solid copper and silver nitrate solution to left because they are reactants. Arrow and yielding copper 2 nitrate and solid silver. So far we have the word equation. Now let's convert the word equation into what? Into formula equation. We're going to replace the names here in word equation by their correct formulas or symbols. So we have copper solid and we have AgNO3 stands for silver nitrate and it's aqueous, yielding copper 2 nitrate. Why copper 2? Why this is here? We have 2, which means copper is positive 2 here. That's why we will have 2 nitrates because each nitrate has a charge of -1. So the correct formula for copper 2 nitrate is CuNO3. If it was copper 1 nitrate, it would be CuNO3 without brackets and without this the 2 here. Plus the solid silver is subtracted, but the work is not done yet because the equation is not balanced yet. Let's get it balanced. We will start with the elements that appear once in both sides combined. So we have how many copper? 1. How many copper? 1. Okay. Leave the copper. We have how many silver? 1 and 1. Okay, leave it now. But we have a problem. We have 2 nitrate polyatomic ions, but we have only 1 here. So we need to get this equal to this, which means the 1 equals to 2. So we will put 2 in front of AgNO3. Now the nitrate NO3 is balanced, but it confused the Ag. That's why we need to put 2 in front of Ag, because the Ag became the Ag became 2 atoms, so we must make the 1 atom in product side also 2. Now we have 2 silver atoms, we have 1 copper atom, we have 2 nitrate polyatomic ions here and there. So it is balanced and our work is done. Okay, now these examples are enough for now. So let's move to section review. About section review, actually, the questions are pretty easy. We don't have a lot of questions. We have only 3 of them. So we will have them maybe within 5 minutes. Okay, in section review, question 1, describe the difference between formula equation and chemical equation. Actually, formula equation is a chemical equation that not balanced yet. Not balanced yet. And sometimes the formula equation is already balanced. So in some cases, in some reactions, the formula equation and the chemical equation are the same term. But anyhow, formula equation is a chemical equation that is not balanced yet. Question 2, write formula equation for the reaction between aqueous solution of sulfuric acid and sodium hydroxide. So we have 2 reactants. We have sulfuric acid is a reactant and sodium hydroxide is a product. You might remember that you studied the reaction between acid and base. What would it produce and what called acid and base react in a reaction called neutralization reaction, and they produce salt and water. So always the products are salt and water. Of course, we don't mean the salt only, the table salt that we for flavoring food, because we have thousands of them. We have thousands of salts. Anyhow, we have sulfuric acid and its aqueous solution, and sodium hydroxide also aqueous solution. Both are dissolved in water. Here, in neutralization reaction, the cation, the positive ion of the base, combines with the negative ion or the anion of the acid, forming what? Forming the salt. And the salt here is sodium sulfate. We have subscript of 2 for sodium. Why this 2? Because sodium is in the group 1 and has ion or forms ion of positive 1, and sulfate has negative 2. So in the front of each sulfate negative 2, we need 2 sodium positive 1. And water. Why? Because hydroxide from the base reacts with hydrogen from the acid, forming water. This is not balanced yet because we have 2 sodiums here, 1 sodium here. We have oxygens also not balanced. So let's get it balanced. But it's actually the question here is only formula equation. It is only formula equation. So the question doesn't ask you to balance it, but let's get it balanced. Here we have, let's use another color. We have 2 sodiums here, we have 1, so we're gonna put 2. Okay. How many sulfates? 1 sulfate, 1 sulfate, no problem. So far we have sodium is balanced, sulfate, because polyatomic ion, is balanced also. So let's move to oxygen and hydrogen other than these in sulfate. So we have here 2 hydrogens, and we have 2 hydrogens also here. We have how many hydrogens here? We have only 2. So we will need to have coefficient of 2 in the front of H2O in order to get the hydrogen atoms for. So we have 4 hydrogen atoms and we have 4 hydrogen atoms here. So also for oxygen other than oxygen and sulfate, we have here 2 times 1, 2 oxygens, and we have 2 times 1 also 2 oxygens. So now we got it balanced, despite the question asks for formula equation, not balancing. Anyhow, question 3, translate the following chemical equations to sentences. Here the question is opposite. And normal, usual questions, we have sentences and we should translate them or convert them into formula equation, later to chemical equation, maybe balanced chemical equation. But here we have equations and we need to describe in sentence. So let's go. We have 2K, which means potassium, solid, plus H2O, water, liquid, yielding KOH, it is sodium hydroxide, plus hydrogen gas evolved, which means released. So we can say here, solid sodium reacts with liquid water, producing aqueous solution, because the solution here is aqueous solution of potassium hydroxide and releasing hydrogen gas. So let's read it. Solid potassium reacts with liquid water to produce aqueous potassium hydroxide and hydrogen gas. We have B is the same. It is an equation, a chemical equation, balanced chemical equation, and it asks us to convert it into a sentences. So we can say solid iron reacts with chlorine gas, producing iron 3 sulfide, chloride, iron 3 chloride. I will not write it because this is your homework. Okay, that's all for today's mini lecture. I wish to meet you in next mini lecture in section 2.1. I wish you get benefit from this mini lecture and have a nice day.